this video we are going to have a look at the rotation parameter, and we will create a rolling animation simulating the attrition of the ball on a plane. First of all, let's start by setting up the starting position of our ball. It is important to be really precise when positioning the ellipse for this kind of animation. For this animation, I chose to use a gradient fill on the ball in order to better see the rolling animation that we are about to create. Once the starting position is set, let's begin the animation by clicking the stopwatch next to the position parameter. Then move forward in the timeline and position the ball at the end of the slope. Once again, the positioning needs to be really precise. Then, to complete our animation, let's move forward a bit more and select the final position of our ball. For this final keyframe, we are going to change only the X value. Now, as you can see, the spatial interpolation path in our viewer shows that the trajectory of the ball will overlap with the plane. In order to avoid that, we are going to select all the keyframes and, through the keyframe assistant window, change the spatial interpolation from auto Bezier to linear. Now we can see our ball moving the right way. Nonetheless, the ball is not rolling down the slope, but rather sliding down. In order to achieve a rolling effect, we need to animate the ball's rotation as well. Let's start by fixing the starting point of our rotation and activating the animation on our parameter. Next, we need to calculate how many rotations we need in order to have a rolling ball without sliding effects. To do so, we are going to reprise some basic notions of mathematics. In order to calculate the length of the slope, we can use the Pythagoras theorem. In any right triangle, the square built on the hypotenuse is equivalent to the union of squares built on cathets. So we are going to use the x and y coordinates of our ball in order to calculate the length of the cathets and then recover our hypotenuse. At the first keyframe, the ball is in position 75.2x and 443.8y, while at the end of the slope it is in position 834.5x and 837.6y. Using the Pythagoras theorem, we can say that the distance d traveled by our ball on the slope is of 855.3 pixels. Knowing this, we can then calculate the rotation value we need. First of all, we need to know the circumference of our ball. The formula for the circumference is 2rp, which translates in the diameter multiplied by p. We can find the diameter of our ball within the shape layer. It is the input size of our ellipse path. In our case, the diameter is 214 pixels. This way, we can calculate that the circumference of our ball is 672 pixels. If we divide the distance we found earlier by the circumference of our ball, we know how many rotations we need in order to make the ball roll down the slope. In our case, it is 1.27 rotations, which translated in rotation and degrees is 1x 97.2 degrees, 1 being the integer and 97.2 being the decimal transposed in degrees, so 0.27 times 360. If we apply this value to the second keyframe, we finally have a correct animation. Now, our ball is not rolling in the second part of the movement, so we need to repeat the procedure. This time, the distance is just the difference in the x position, which means 718 pixels, giving us a new rotation of 1.25.5 degrees. In order to have a fluid movement, we need to sum this value to the one in the second keyframe, and we get a final rotation of 2 times 122.4 degrees. Finally, our ball is rolling in the correct way. The final touch of the animation is to simulate attrition and thus slow down the rolling ball. To do so, we are going to work in the node graph and to adjust the temporal interpolation for the X animation and the rotation in the final keyframe. Let's set the temporal interpolation to easy ease and control the two keyframes at the same time. It is important, in order to have a good animation, to make sure that the central keyframe is set on a linear temporal interpolation. Once we complete our animation, we can review the timing by moving our keyframes in the timeline. In this case, it is important to move them all together in order to keep the animation synced. And finally, we have our rolling ball.